Hello again and welcome to Demonary Coding School. We're today learning course 102. Now that we understand the basic of programming in C, we approach the problem of coding correctly in said language. So the subject we need to approach is what is our part when entering a new codebase, both as a user of the codebase and as a contributor. What the codebase need to provide us, comments, where and why. When do we use comments? Why do we use comments? And where is very important, especially when working with multiple people. Coding style and why it matters. C, like many low-level languages, requires programmers to choose a coding style. That coding style can vary, but maintain a certain set of patterns. Those patterns are maintained across all of the code that is used within a single codebase. Multiple codebases can have different styles, but a single codebase should have a consistent style for both contributors and users to be able to parse the codebase correctly. Correct use of header files and function manuals, both how to read and how to write those. And finally, macros, the preprocessor, and compile time programming. Those are the subjects for 102, and we will discuss them shortly. Those subjects should allow us to approach any codebase in C and integrate with its development or use without increasing the workload for project administrators and seniors. It should also reduce our workload in the future, as we would be able to infer greater detail from our code at simple glances. So, like Martin Sitterpants, let us begin. When we import some codebase in C, as the user, we are going to have this header file. This header file is going to include all of the functions, and we are required to read the description for each of those functions in order to know what we are calling and when we should call it. When we enter a codebase, the first thing we do is we go to those header files. They are our API, our documentation. That documentation is the contract between the developer and the user. If we didn't read this, we would cause memory leaks, because we wouldn't know that we need to destroy our stack at the end of its use. Of course, all of those receive very intuitive values. As you can see, capacity and element size you would know them immediately when you see them. In C programming, the object we are referencing is put as the first parameter, always. We have the base object, and then we would have other parameters. We can see that it tells us what type of things we do. We are not guessing. Description. Function removes the element from the stack and return it. Trying to pop an empty stack will result in undefined behavior. This is part of programming. You should inform your users that they should not call a function in places where it doesn't make sense to call that function. Now, undefined behavior may be something that you don't need to worry about, but undefined behavior is there because it might cause something that is implementation dependent, and therefore is something that you should not rely on as the user of the library. So this is the approach, how we approach a codebase. This is something that is required of us. And we can go to the second part of entering codebase, as a contributor. As a user, we just read the header file, which includes all of the documentation. We don't need the C file, which is the implementation. Documentation, implementation. Two different things. One is required for everyone to learn, and the other is not. Now, as a contributor, you must also read the implementation detail. As a contributor, you are expected to make changes and suggestions to that code, so you're expected to read it. When we read the implementation detail, what do we see here? We see very little comments. We see a comment about what is the define. We see approval comments, who approved that code when this code is pushed to database. We see the includes and what those includes are used for. This O size of element, it is due to the complexity of memmove. Memmove is using a loop that is copying the data in element to push into our stack top. Comments where and why. Sometimes our code can be complicated, and sometimes we might want to have those very complicated and not understandable things commented. It is difficult to find code in this project where I actually commented on the actual code, because this is very much library development. Basically, most of the code is supposed to be self-documenting. Let me see if I can find something, maybe in the C++ examples. This comment relies on internal implementation detail of this library. It is very far removed from our code, and therefore it justifies a comment. And when you look at the actual function here, you can see that there are comments that describe what this section of code does. And all of those. And we can see from the comments why we chose to do all of those. You can read this entire piece of code, or you can read this comment. And this is why comments are important. Even in self-descriptive code, which this is very self-descriptive. If you actually read this code, you understand what it does. But why read all of this when this works? This is one line of comment. We found our comments. Most of the comments are in documentation. Sometimes we want to have documentation on why we do certain things. One point I forgot to address in the C++ headers is that C++ headers are usually documented outside of the header file. This type of header file, which also include implementation detail, because it uses templates, all of those things would not be something that would be read by the users, but instead they would have a README file that does everything that a C header used to do in a format that is just as readable. And for more information about GLM, please have a look at the manual here and API reference documentation. Instead of reading header files, we now use those things. Getting started using global headers. Here you can see to extend a feature set, those are for contributors. And here is the actual function documentation. GLSL apps man page. You have an actual link to the man page itself from Kronos.org for the GLSL language, and this is the GLM for the same functions but on the CPU side, meaning like in your process instead of in your shader. And you can clearly see how things are used. This is a contributor page, basically everything you need to read as a contributor. The API documentation for everyone who uses the header. Everyone who uses the library must read the documentation before using it. Language style guidelines and why we need them. When programming in C or other similar languages, we want our code to reflect its function. It begins with choosing names for our symbols. Most C and C++ books contains sections discussing this very subject, which helps us denote our code from even the basic symbols we use. I can give examples of my C and C++ style guides, as I use very common styles that are shared between a lot of other programmers that use C and C++. And those styles allow us to easily differentiate between the types of symbols by their name. For the C guidelines, enum use macro case for their values. Each enum name is written in macro case with the suffix _e. Structs are written in camel case or are left unnamed and then typedef with camel case that uses the _t suffix. Macros use macro case. Function use Pascal case, where a prefix written in Pascal case as well of the object name they are operating on for functions that operate on objects. Stack create is a good example. We know that we are working on a stack object and that the function is create. Members, variables, and parameters use snake case. Global variables use the _g prefix with snake case. This allows us to know that we are working with a global by simply looking at it. The differentiation between variables and parameters doesn't matter for us because we are operating inside relatively readable functions. Our variables are declared at the start of the function alongside the parameters, and our members have their prefix of the struct. So we have the struct variable prefixing the member. These simple styles allow you to always know what type of symbol you are referencing from the code itself, as C doesn't have a hidden this reference. For C++, the guidelines change a little bit. Let's see that in practice. Parameters are set with a certain naming convention. Members are set in a certain naming convention. Yes, this is old C programming, so parameters passed to a function and member variables don't have different naming conventions here. In C++, you add m_ for members. This is a very common way of signifying members, and s_ to signify static members. Each of the members exists inside of each object, and statics are shared between all objects of the same class. That is why those naming conventions matter, as we signify the difference between a static define and a parameter. I will go a little over how you write them now. And basically every function needs to have this pattern when you want it to be well documented. You don't need to have those in all of your functions, but if you want to be as by the books as possible, every function needs to have this documentation style, which includes a description of the function, a section describing each of the parameters, basically the return parameter, and maybe another section for side effects. After all of those, you can add an algorithmic order. All of those are covered in what you need to write when you describe a function. Simple human language description. Parameters with each parameter and a description of what it does, what it holds. As you can see for capacity, for example, max capacity in elements. So we know what it is, and we know the unit of measurement. So when we use it in our code, stack create array size of test variable, and we know from our function immediately what each of those do. Now, yes, instead of doing this, I can just write a number and it would be just as descriptive. This is just as descriptive as this. And you know why? Because stack creates this with a size of tells us exactly what we are creating. We create a stack with those many elements of this size, because here is a size of. We know that this is a size because it's a size of. It's very simple. And what other number would a stack need outside of a size of? The number of elements. Plain numbers are only bad when they are not described properly. And numbers inside of a function call are described properly because the function call puts them into context. Now, if you're passing just a random pointer here, you're breaking the contract that we made when you decided to use this library, because that documentation is the contract between the developer and the user. So those are basic manners. How do we contribute? First, reading stuff, seeing how things are done, and doing basically everything that we need to do in order to understand how code is kept maintainable. The macros, preprocessor, and compile time programming. This is why macros and constants are important. With all of those subjects covered, we finished Coding School 102, How to Have Manners.